Today we're talking about vectors, equations, and lines. Okay, so now we're going to move a little bit more to the application aspect of vectors. We're going to incorporate the properties and how to find angles, and incorporate them into vectors. When I looked through and saw like how much was left for vectors, my goal is to hopefully finish up everything for vectors this week, and then we'll test like the last, like the Friday after we get back from Labor Day. So that's the plan for right now. So starting out, okay, we can determine the equation of a line using its direction at any fixed point on a line. If you think about it, back when you learned how to write the equation of a line, right? You did 2 points. When you create the equation, you put into y equals mx plus c form, where the m stood for the what? The slope. The gradient, right? That told you the direction in which that line was heading, and then what would it be represent?
The y-intercept.
Your y-intercept, okay, so that was your fixed point, essentially your starting point, okay? In 3D, your lines are now in space, okay? So this equation here that you see, this is a bolded r equals a bolded a plus lambda bolded b, so these are vectors. When you have to write a vector, like you would on a quiz or a test, or the IB exam, you want to make sure that you include the arrow notation over your vectors.
Pretty sure
Okay? So even though this is printed for you and it's already bolded, I'm going to go back through and emphasize the fact that you, when you yourself have to write a vector, you need to put the arrowheads over both of those, okay? So all your vectors, make sure you include your arrowheads. But basically vector R equals vector A plus lambda vector B. Okay, so essentially what's happening, you'll see it on your next slide and here, and then also on your notes, is that you essentially have a point R on a line with a position that is vector R. Suppose the line passes through a fixed point A with a position that is vector A. Let me go back through and add these arrowheads in. And a line that's parallel to vector B. Lambda is a scalar, which is essentially any real possible number. And so this equation is created because if I'm essentially trying to go from A to B, I'm essentially using the triangular notation, or I'm essentially, triangular form to add the vectors, and that's where you get A plus lambda B, okay? And then realize that B is the direction vector of any equation that you get. So whatever vector is attached to that scalar, it could be lambda, it could be mu, it could be t, it could be s, it really could be any variable. But whatever vector is attached to that scalar, that is the direction of that vector. Whenever you're trying to figure out if lines are perpendicular, or if, and you're given the equation, you're going to use the direction vector to figure out if they're perpendicular. If you're trying to figure out if the lines are parallel, you're going to use the direction vector. So vector A is that starting point, it is that fixed point, but B, that is the magic one, that's the one that we're going to use for essentially any type of the operations that we do, okay? There are different ways that you can write an equation. You have your vector equation of a line, which is essentially, what we saw before, where you had R equals A plus lambda B. R represents the X, Y, and Z. A is vector A, the B is vector B. You can also have the parametric equation form for these, which essentially is actually creating 3 different equations for X, Y, and Z. And then there's also the Cartesian equation form, which essentially is where you take each one of these equations in the parametric form and solve for lambda and equate them to each other. That's Cartesian equation, okay? And so you can go from one to the other, forwards and backwards, okay? So we have an example. It says a line in space passes through the point 1, -2, 3, and in the direction of 4i, 5j, and 6k. Of course, these will be bolded, so they're vectors, so we're going to go back through. We're going to describe the line using a vector equation, parametric equation, and Cartesian equations, so you guys can get the practice of actually doing this. So remember, vector equation, that's the one with your x, y, and z. That should equal vector A. What's going to be vector A? 1, negative 2, 3 is that fixed point. And since it passes through this point, that's going to be the A vector plus lambda vector B. What's going to be vector B?
4, 5, negative 6.
4, 5, and negative 6. Yes, it's in base vector form, but we can write it in component form. So essentially, we were taking the fixed point to use to create the vector equation. Now how to write the parametric equation? Okay, this is essentially where you're taking your vector equation and you're just essentially combining your 1s, your 2s, your 3s with your x, y, and z. So then what would be the parametric equation for this particular situation?
X is equal to 1 plus 7, 4.
Mm-hmm. But usually, you know, the variable goes afterwards. Yeah.
Mine just makes it. Y equals negative 2, 5 lambda. Z equals 3, negative 6 lambda. Or 2, yeah.
Okay. And then the Cartesian is essentially when you solve for lambda for each one of those parametric equations, and then you equate them all together. So if I were to solve for lambda in that very first equation, the x equals 1 plus 4 lambda, what would I have? X minus 1 over 4, because I would have to subtract 1 to both sides, and then divide both sides by 4. Then what about the second equation, y equals negative 2 plus 5 lambda? Y plus 2 over 5. Because remember, all I'm essentially doing is I'm just solving for lambda. So that means I'm going to add 2 to both sides and then continue to get lambda by itself. So I divide both sides by 5. And then for the last part,
Z minus 3 over negative 6.
and it's okay for you to leave that negative in the denominator. Okay? Because then you'll just be trying to, you know, correct something, and then it might throw you off and make the whole thing wrong.
You can just plug the numbers into the blank one.
Say it one more time.
I said you can just plug the numbers into the blank Cartesian equation.
You
Or
could.
were you just showing us how to go from equation to equation?
Yeah, because like, let's say you forget how to do this, then you can always essentially solve for lambda. Yeah, but you could really, you know, just plug that in and just remember it's minuses on top. And we're good to go. Okay? Easy peasy.
For now.
It'll stay that way, I promise. All right, with vectors, you have to be careful with equation you do create, because remember, we are talking about direction. So if we have 2 points and we're trying to find the equation that represents this particular situation, if I use 5, 4 as a starting point and it has a direction vector of 2, negative 1, then my equation is going to be this, okay? Vector r equals 5, 4 plus lambda 2, negative 1. But if I use 7, 3 as essentially my fixed point, then I'm technically going in the opposite direction, which means that I would need to negate the direction vector, okay? So be cautious of which point you use as your fixed point. A good rule of thumb, use the first point that's given to you. That way you won't have to worry about negating the vector because you're going in the opposite direction, okay? All right. So we're going to find the parametric equation for the line that passes through 2, negative 1, 4, and b, negative 1, 0, 2. Well, in order to write the parametric equation, we need to know our direction vector, which means essentially we need to figure out the vector in the first place, okay? So anytime you're given a point, you need to find the vector, and in doing so, you're finding the direction vector because you're finding it from A to B. We talked about this before your quiz. How do I find that? I do B minus A. So then that's going to be negative 1 minus 2, 0 minus a negative 1, 2 minus 4. What does that equal?
-3 and -2.
You said it so fast.
Sorry, -3, 1, -2.
Very good. So this here, this is our direction vector. This is what's gonna go in for that B if we were to write it as a vector equation, okay? Now, by all means, you can write the actual vector equation and then convert it to parametric. There's nothing wrong with doing that. We just wanna make sure that we write it as a parametric equation, okay? I am gonna do that to start out with until we get to that point where we won't need to do this. And we can just go straight to parametric. So what's gonna go in for this A vector?
2, -1, 4.
Very good. And then what's,
-3, 1, -2.
very good. Now we could also use the point for B. We could very much use the point for B. We just have to be sure that if we used B, what would be our direction vector? The negative, okay? Because instead of us going from A to B, we would be going technically from B towards A, so we're going in the opposite direction. So then this would be 3, -1, +2, but this would also be correct as well. Okay, and if you notice, I did use a different scalar, okay? Because essentially this is a different equation, okay? Oh, there's no section. All right, so now let's write it as a parametric equation, which is essentially just equating each one of these pieces. So my final answer is what?
So it's parametric.
Yes, the parametric equation.
X equals 2 minus 3 lambda. Y equals -1 plus lambda. Z equals 4 minus 2 lambda.
There we go. And if I used B instead, the lighter blue color, then it would essentially be the same thing. I'll just have mu's, and then it'll be -1 plus 3 mu, negative mu, and then 2 plus 2 mu. Let's take a look at this one. We are told that line L1 has the vector equation R equals what you see there. And then it says that line L2 passes through those 2 points. You have to find the equation of L2. Okay, let's go ahead and find the equation of L2, and then we'll do part B together. So if I want to write the equation of L2, did you write it as a vector?
Mhm.
Okay. All right. So just to review, mostly for you, what does A represent in general?
Starting out.
The
Yeah,
fixed
starting
point.
point.
The starting point, the fixed point. What did you use for your fixed point?
Here's the first one, 2, 0, 3.
2, 0, 3. Okay. And then what does B represent?
Direction.
The directional.
And I find the direction by doing what?
Second minus the first one.
Mm-hmm. You said -2 minus what?
-2 minus 2.
And then 1 minus 0, 3 minus 3.
Very good. So then what is B?
-4, 1, 0.
Awesome. Good job. Now it says that line L3 is perpendicular to both L1 and L2 and cuts the z-axis at -2. Okay? First off, if it's perpendicular, what does that mean?
Dot product 0.
Mm-hmm. But this one is 3. So what do we do there?
Did you say dot line?
I believe you said dot.
Yeah, dot.
Okay.
Dot product 0 is perpendicular.
Right, but that
You can't do.
but we're in space though. So we're gonna have to do the cross product.
Yeah.
We're gonna have to do the cross product. And since it says that it's perpendicular to both of them, we're gonna need to use the direction vector for both L1 and L2, okay? Then that will give us the direction vector for L3 in order for it to be perpendicular to the 2, okay? So that's something that we did last week. We're gonna do the cross product between L1's direction vector and L2's direction vector. Okay? You guys go ahead and do that. That's something that we did last week. So we get -4, -16, and 3. Remember, we have to do 1 times 0 minus 4 times 1. Then you do 4 times -4 minus a -1 times 0. And then -1 times 1 minus 1 times a -4. And that's how you get -4, -16. You said 3?
Yep.
Okay. So now that we have that, this is our direction vector for L3. And it says that L3 cuts the z-axis at -2. And directly, they're giving you your fixed point. How would I represent that point when it crosses the z-axis at -2?
0, 0, -2.
Very good. 0, 0, -2. So now I have my A vector, I have my B vector, and so I can essentially write my equation. It is asking for Cartesian form. Do you want to go straight to Cartesian form, or you want to go the 3, like from vector to parametric to Cartesian?
I wrote it as a vector.
Go as a vector, okay? So then if I wrote it as a vector equation, that would be x, y, z is equal to what?
0, 0, -2 plus lambda directional.
So this is it as a vector equation. If I wrote it as a parametric equation, it would be what would it be as a parametric equation? Very good. And so now we can write our final answer, which is what they were asking for in the question. And remember, we get that by essentially solving for lambda in each of them and equating them to each other. So my final answer is going to be
Wait, what? Never mind.
you gotta solve for lambda in each equation. How would I solve for lambda in the first one?
Down -4.
So that'd be x over -4. What about in the next one?
Y divided by -16.
And what about in the very last one?
Y plus 2 over 3. Or z plus 2 over 3.
And there we go. That's our final answer. That's the Cartesian. Questions on how to write equations? So, same rules apply for parallel and perpendicular lines. So remember, parallel lines meant they were scalar multiples of each other. Don't forget the two parallel lines from geometry, that symbol does mean parallel. Perpendicular, yes, you do have the dot product if you're looking two-dimensionally, equals 0. And then also cross product, 3-dimensional, so just be careful of that, because you can have some equations that only have an x and a y, but then you can also have some that have x, y, and z. So just be aware of that. Because we are dealing with lines, you can have lines that coincide, intersect, and be parallel as well as skew, okay? And so just to review those words, coincide means what? Say it again. They're on the same line. Essentially, they are the same line. Okay, that's what coincide means. They're essentially the exact same line. What intersect? That's pretty straightforward, right? Two lines, they intersect at a what? A point. Parallel means?
They're parallel.
Meaning?
They don't cross.
They'll never cross. or touch, but they actually lie in the same plane. So if you look at like a three-dimensional, like a cube or whatever, these two things right here, they would be parallel. Okay, they don't intersect each other, they don't touch, but they lie essentially within the same plane. What does skew mean? This is like way back geometry, like first unit. No one knows what skew means?
Yeah, that's not really.
Essentially,
That's different planes.
huh?
Said that they're on different planes.
They're on different planes, okay? They are on different planes. They are not the same line. They do not intersect each other, and they are not parallel. So skew lines would be something like this line right here, and then this line right here, okay? They lie on different planes, and they'll never cross, intersect, nor will they be parallel, okay? If you are trying to determine if lines are any one of those three, you will want to look at the direction vector of each line and essentially go through, a series of different processes. So we're going to look at a few examples of lines and determine if they're parallel, they intersect, if they do, what point, skew, et cetera, et cetera. So if they're parallel, don't forget they're scalar multiples of each other. So here, what form are these two lines written in?
The vector.
This parametric. So you need to pull out the direction vector from both of them. From L1, what would be our direction vector?
-3, 1, 2.
Exactly, -3, 1, and 2. Because if you think about it, remember our direction vector is the vector that's attached to our variable, okay? Our scalar. Here it's t for the first one, it's s for the second one. So that'd be -3, a +1, and then a +2. What's the direction vector for L2?
6 that you're taking with it.
Are these two scalar multiples of each other?
Yes.
What's the scalar?
-2.
Okay, so L2 is, you said -2 of L1, therefore they are parallel. Parallel's the easiest one to check first, okay? So if you're given two lines, you're trying to determine if they're parallel, see if their direction vectors are scalar multiples of each other. If they're not, then let's see if they intersect. Intersect's the next easiest one to find, okay?
That's all you have to write for the show problem though?
Yes.
Okay.
Show the scalar, show the connection between the two lines, and then of course, state that they are parallel. To find a point of intersection, you're essentially going to solve simultaneous equations. That's systems of equations, substitution, elimination, okay? So, we gotta add in our vector pieces. L1 is xy, -2 plus s times 3, 2. Line 2 is xy, 15, 5, t, -4, +1. Find the point where the two lines meet. Already we can see by looking at their direction vectors that they're not parallel. One is 3, 2, the other one is -4, 1. They are not scalar multiples of each other, so we know automatically they're not parallel. Also it says find the point where they meet, so we know they're intersecting. How do we find the point where they intersect? What we have to do is we have to actually set up our system, okay? And essentially what we do is we take the x components of both L1 and L2, set them equal to each other, and do the same thing for the y's. So we're gonna have -2 plus 3s is equal to 15 minus 4t.
Coach, is out the door.
And then we'll do the same thing for my y's. So what's the equation for the y's?
1 plus 2s equals 5 plus 2.
Very good. And hopefully we haven't forgotten in our senior year how to solve a system of equation. Okay? Hopefully not. Which method do you want to use, substitution or elimination? Elimination. So that means we want to get our variables on the same side, our constants on the other side, and then on top of that, we want to eliminate one of our variables. So I'm going to go ahead and do this, right? I'm going to go ahead and add over my 4t, and then add over 2. And then here I'm going to subtract over t, and then subtract over the 1. So that's what those two equations simplify down to be. Which variable do you want to eliminate?
T.
Which means I have to multiply
Bottom by 4.
the bottom
By 4.
by 4. Okay, so then that's going to give me 3s plus 4t is equal to 17. On the bottom, that will give me 8s minus 4t is equal to 16. When my t's cancel out, that gives me 11s is equal to 33. So s is equal to
3.
very good. Now, just like with the system of equation, we want to find t as well. We want to find our other variable, which means we have to take s and plug it back into
One of them.
3s plus.
one of the equations. My suggestion, you always plug it back into the original, okay? So if I plug 3 in for s, what does t equal?
2.
2?
Makes sense.
It is 2.
Yeah, 2.
Okay, so do you need both? It doesn't hurt because it kind of confirms for sure that this is the point of intersection. Once we got s was equal to 3, we could have plugged 3 in back into L1 and find the point. Okay, that is how you do it. But you can also use 2 and confirm that the point you got for L1 is the exact same point. Okay, so that's exactly what you want to do. You want to take -2, plug in 3, find the x coordinate where they intersect, and then plug in 3 and find the y coordinate. So then -2 plus 9 is,
7.
and 1 plus 3 times 2.
7.
So the point of intersection is 7, 7, or the point where the two lines meet is 7, 7. I can confirm this by plugging in 2 in for L2. That's 15 plus 2 times -4, and 5 plus 2 times 1. This is 7, and this is also 7. So it confirms that that is the intersection point. Here we go. We're going to show that the lines are skewed. How do you do that? You basically show that they're not parallel, and you show that they do not intersect. That's how you show that they're skewed. Okay? And also by showing that they're not parallel is also showing at the same time that they don't coincide as well, because otherwise it would be the same direction vector. Okay? So let's go ahead and let's pull out the direction vector for each of these. L1, what's the direction vector?
4, -4, 5.
And what about L2?
8, -3,
1.
And so we can see here they're not scalar multiples of each other. And we can also see that they do not coincide, okay? Because they're not the same. Therefore, they're not parallel, nor do they coincide. So the last thing we have to do is to check to see if they intersect, okay? So that means we have to go through and we have to solve the system. So that's going to be 1 plus 4t is equal to 2 plus 8s. 5 minus 4t equals 4 minus 3s. -1 plus 5t equals 5 plus s. Now if you notice, this is 3 equations, but there's only 2 variables, which means
you can pick one.
you can pick just 2 of them to solve for your variable, okay? And then the equation you don't use is the equation that you use to confirm that they don't intersect, okay? Because if they did intersect, whatever value you get for s and t should make a true statement. The left side should equal the right side.
Then we should use the first two.
So we're going to use the first 2 to solve for our variables. If I take these first 2 equations, we can see that the t's will eliminate. That gives us 6 equals 6 plus 5s When I subtract, that'll give me 0 equals 5s, so then s is going to be equal to 0. If I plug 0 back in for s and I solve for t, what do I get?
I don't know, I didn't get that far.
1 4.
So,
I don't know, I just guessed.
It is 1/4, because when you
Yeah.
plug this in here, this cancels out, subtract over the 5, so you'll have negative 4t equals negative 1, and then divide by negative 4, and you get 1/4. So, how do you show that they do not intersect? That last equation that you did not use, when you plug in the value for s and the value for t, they should not equal the same thing, okay? They should not equal the same thing. So when I plug this in, we can already see that 5 does not equal,
1 4.
so therefore they do not intersect, which means that they have to be skewed. If they did equal each other, then that means that they would intersect, and then you could find the actual point of intersection by plugging t and s into the original equations.
I meant to mention to let me wear it Friday.
Oh, that'd be amazing.
So remember, we need our direction vectors. Oh no, actually no, we don't need our direction vectors because we're trying to figure out the intersect. So let me not do anything extra. I need my equations though. What are my equations?
1 plus 2t. 3 equals 4 plus 3s.
Mm-hmm.
3 minus 4t equals 4 plus s.
Mm-hmm.
And negative 2 plus 4t equals negative 4 minus 2s.
There we go. So as we can see here, I don't know which 2 equations did you guys use?
Bottom
I
shit.
did.
I definitely would have used the bottom 2 and solved for.
S.
So by doing that, you'll get 1 equals.
Negative s.
So s is equal to.
Negative 1.
And when you plug it back in,
T is equal to 0.
does anybody need me to work that out?
Do you have to work it out for show problem?
Not necessarily. I mean, you've already done this part, eliminated, solved. But you definitely want to go back in and show the plugging in part. So 1 plus 2 times 0 is equal to 4 plus 3 times negative 1. So then that'll give me 1 is equal to 1. Therefore, they intersect. Questions on intersecting lines, parallel lines, skew lines? Yeah.
I have a random question. So you know how like this,
Alright. The shortest distance between a point and a line is a perpendicular line. Okay? That goes back to trigonometry. Anything. Shortest distance between 2 points is a straight line. Between a line and a point, it is a line that is perpendicular. So you're looking at the dot product between a vector, which is from the point to a point on the vector, the dot product between that vector. Okay? So it says a line has a vector equation, xy equals 1, 2, plus t, 3, negative 1. You want to find the shortest distance from the point P, which is at 5, negative 1, to the line. Okay? And so in order to do that, we would need to do the dot product, set it equal to 0, and then from there, we can figure out the actual distance by finding the magnitude of that vector. Okay? So, we have to figure out what this vector is though. Okay? So, suggestions on how we do that?
Added this to, yeah, the 3, negative 1 to the p.
Say again.
Add it to the p.
Add what to the p?
3, negative 1.
Now remember, this is just the direction.
Oh.
Specifically, you need a point that's actually on this vector. So you actually wanna take the full equation itself and, essentially go from this vector B and this point P, essentially you need to figure out this right here, okay? This is that PR that you need to find, okay? So then to do that, you would essentially need to take the vector and subtract it from P. So that is the X value, 1 plus 3t minus the actual point P. So this 1 plus 3t essentially represents that point that's straight across from P, then minus the 5, and then 2 minus t, again this point, minus -1. We are doing r minus p to find vector PR. This will give us an expression, which is fine, okay? This will give us an expression. And then we use that expression and do the dot product with B. So when we simplify this, this gives us -4 plus 3t and 3 minus t. That is vector PR. We do the dot product with PR and vector B because it is perpendicular, so we're going to set it equal to 0. And in doing so, we'll be able to solve for t. So we're going to perform the dot product between that and what piece? What represents B? 3, -1. So when I do dot product, how do I do that? When there's an expression involved.
Be 3 times -4 plus 3t.
It'll be 3 times -4 plus 3t.
And plus -1 times 3 minus t.
And all that's going to be equal to 0. And so we do some algebra here and we find the value of t. Okay, so do that algebra and find my value of t, please.
1.5.
Sure.
I think so.
1.5. Considering this is a non-calculator problem, what would that be? 3/2. Okay. Yes, that would be 3/2.
If this is simple decimal, can you still put it as a decimal?
Yes, but considering that I have to do more with that decimal, I'd rather it be a fraction than the decimal. And I only say this again because I have to use that t. I actually have to find what that vector is, that PR vector, and then I have to find the magnitude of it, which means I gotta square it. And so I'd rather square a fraction than a decimal. That's just me though. By all means, knock yourself out on non-calculator with them decimals. All right. So now that I have the value of t, I can figure out what PR is equal to because I can plug that back in. When I plug in 3/2, what is PR? You said 1/2. I can't hear it over the Skittle bag.
1/2 and 3/2.
1/2 and 3/2. Can I get confirmation?
Yeah.
Yeah.
I didn't do the math, but I'm pretty sure it's right.
It works out.
So now that I have PR, I can now figure out what the shortest distance from that point to this line, okay? Because again, PR is essentially this vector right here. We're trying to figure out what is that distance. I know the shortest distance between a point and a line is that perpendicular distance. So that's why we did the dot product to figure out what value of t is going to give us essentially that point R to make it perpendicular. So let's find my magnitude of PR, and that's going to give us our shortest distance. So remember, magnitude is you take each of the components and you square them and add them together. What's 1/2 squared?
4.
What's 3/2 squared?
9
When I add it together, I get,
10 4.
and is either of those a perfect square?
Yes.
4.
The 4. So the shortest distance is root 10 over 2 units. That is the shortest distance from a point P and that vector equation. We have another point P, -1, 2, 3, and the line with the parametric equation that's given to you. This is a -4 plus 3t. T is a real number. We want to find the coordinates of the foot of the perpendicular from P to that line. In other words, it's asking you to figure out what is this point right here. That's what it's asking you for, okay, in part A. And then part B is actually asking you to figure out the distance. So essentially, the same thing that we just did. See if you can do it on your own. This is supposed to be a T. Let me catch all my typos this time. So you should have had, yes, this was written as a parametric, but you could have written it as a regular vector, okay? So then this would have been 1, -4, +3, then 2, 3, and then 1. And since you're trying to figure out the coordinates of this point, just like we did in the last problem, you have to take this equation, essentially this point, which is 1 plus 2t, -4 plus 3t, and 3 plus 1t, and then take that and subtract it from P. So that'd be a -1, 2, and 3 to actually get the vector that represents PR. So you should have had 2 plus 2t, -6 plus 3t, and then a regular t, and that is PR. Questions on that? Just like we did in the last problem, that's what we did right here in the purple. We took the vector, subtracted it from P, because that's how you would find a vector PR. You have to do R minus P. We don't know what R is, that's why we use the general expressions to represent it. And since it is perpendicular to that vector, then we have to do the dot product with vector B, which is what? 2, 3, 1. That has to equal what in order for it to be perpendicular? 0. So that becomes 2 times 2 plus t, 2 plus 2t, then 3 times -6 plus 3t, and then 1 times t, and equal to 0. If I combine all my terms, that's 14t minus 14 is equal to 0. 14t is equal to a +14, so t is equal to a +1. And since t is equal to a +1, we can find the coordinates of essentially R by plugging in that value into the parametric equation or to the vector equation that I created up there, okay? The x coordinate comes from plugging in 1, the y coordinate the same way, the z coordinate the same way. So what's the coordinates of the foot of the perpendicular? 1 plus 2 times 1?
3.
-4 plus 3 times 1? 3 plus 1? Now to figure out the shortest distance, you actually need to plug T as well into PR and then do the magnitude. When I plug in 1 for PR, what do I get?
4.
4.
Negative 3.
-3
1.
and 1. So I have to do the magnitude of PR to actually find the shortest distance between P and the point on the line. So that's 4 squared plus -3 squared plus 1 squared. 4 squared is
16.
-3 squared
9.
and 1 squared.
20,
What is that?
26.
Does that simplify?
No.
So then the shortest distance is the square root of 26 units. How to find the angle between two lines, okay? For lines that continue indefinitely in both directions, we use this formula. It is slightly different for how we find the angle in between two vectors because it is two lines, okay? The difference is that you actually are finding the magnitude of, it's absolute value of the dot product, let me rephrase. All right, so our B1 and B2 are direction vectors of the different lines, okay? So you have two lines that are written in parametric form, but that's okay because all you really need is the direction vector from both forms. What's the direction vector from L1?
12, 5,
And what about from L2?
3, -4.
Okay, you see how they use different scalars because you have two different lines, okay? You want to make sure that if you ever have to write multiple lines in your homework, you use two different scalars, S and T, lambda and mu, so on and so forth. So this essentially would be B1, this will be B2, and then you do the math, okay? The numerator says you have to do the dot product of B1 and B2. Dot product means I would need to do what?
12 times 3 plus 5 = 4.
12 times 3 plus 5 times -4. The denominator of the formula says I needed to do the magnitude of both vectors. So remember, magnitude is nothing but the components squared and added together for both of them.
On the sheet, why does it say the magnitude of dot product?
No, it's not absolute value.
Oh, okay.
13 and 5.
So this becomes 13 and 5. So the bottom is 13 times 5. What about the top?
16.
16. So I have the cosine of theta is equal to 16 over 65. To find my angle, I have to do the cosine inverse of that fraction. And that will give me the angle between my two lines. Questions?
7 degrees.
Thank you. Alright. That one was a pretty easy one because they already gave you the vectors, okay? Just in a different form. This one's a little bit more implied, okay? Because it actually gives you like old school equations of lines and you have to find the angle in between them, okay? For this, you still need essentially the direction. Direction for lines is equivalent to what? Slope, okay? So you need the slope of both of these lines. Y equals what? What's this when I write in y equals mx plus c form?
Plus 5.
And then what about this one?
Negative 3x plus 8 over over -2.
So -3 over -2 becomes a, So this is what this line is in slope gradient intercept form. Be careful, okay? This is B1, this is B2. The direction vector is the gradient, but gradient is what over what? Rise over run, or y over x. And remember, when we write direction vectors, what number's on top?
X.
So you gotta do positive 1 over negative 2, and here you have to do 2 and then 3. So be careful with that. Because remember, in directions or in vector form, x's are on top and y's are on bottom. But slope is rise over run, which is y over x. So when you actually go to find the angle in between the two lines, you have to essentially flip the gradient. That's the only tricky part about that. The dot product between the two becomes 1 times 2 plus negative 2 times 3. What's that?
8. No.
Negative 4.
8.
But remember, it's supposed to be positive. Remember, it's the absolute value of that. So it's going to need to be a positive 4 when we do it in our thing. The bottom is the magnitude. What's 1 squared plus negative 2 squared?
5 squared.
Square root of 5.
Square root of 5.
And then what about 2 squared plus 3 squared?
13.
So this becomes the square root of
60. No.
65. So to find my angle, I'm going to do the cosine inverse of 4 over the square root of 65. Remember, the top is the absolute value, so it has to be the positive 4, not the negative 4. These are lines, not vectors. What is my angle?
60.3.
60.3?
This one.
And that's how you find the angle between two lines.